Hi guys, welcome back. This is section 2.9 when we're going to talk about complex zeros now. What are complex zeros? So we're going to review a little bit about numbers first, just to bring you back down to it. Complex numbers are the largest number system there is. Okay, and let's see. I'm going to kind of erase some of this stuff I wrote. Okay, so you start out with the number system, and I'm going to just use red real quick on here. So you have the natural numbers. So they're the counting numbers like 1, 2, 3, 4. Then whole numbers added 0. And then the integers added plus and added really negative. So you already had the plus. And then rationals added your fractions, a over b. And then you had things that couldn't be written like a over b, like the square root of 5. And so we called those irrational. And then there was a group of numbers that were both rational and irrational. We wanted to group those together, and those were called the real. So that would be like, it's all of these, but it also includes like 2 plus the square root of 3. And we use those, we get those numbers and those answers sometimes. We just did when we were doing irrational zeros. Now, there's something to the side of real called imaginary. So if it's not real, it's imaginary. And those numbers are like I. It could be 2 plus square root of 3i, I square root of 3. So the number system that includes both imaginary and real, all real, is called the complex number system. And so really, we call it complex when you add in the imaginary numbers. All right, so basically we're going to be talking about getting answers that are imaginary, and you have to be able to, so when you want to find all the roots, some of them might be imaginary. And so you've got to be able to do it. All right. So let's do the first one. We have x to the 4th minus 4x squared minus 12. So we're going to start out using a equals x squared. This is a quadratic pattern. So we'll have a squared minus 4a minus 12. And factoring that gives us a minus 6, a plus 2. And putting x squared back in, we get x squared minus 6, and we get x squared plus 2. Now this one's like we did before when we solved for 0, both sides for 0, both factors for 0, we get x squared equals 6. So x equals plus or minus the square root of 6. So we have that guy. That's irrational. But look what happened when we set this equal to 0. We get x squared equals negative 2. So now we have a negative over here. So when we take the square root of both sides, we get plus or minus the square root of negative 2. Now you might be wondering, what is I? I'm going to refresh your memory over here. Say we have a negative square root of 6. We can call this an imaginary number if we remember that we can go negative 1 times 6, and the negative 1, I squared equals negative 1. So the square root of I equals, taking the square root of both sides, I equals the square root of negative 1. So you can say I equals the square root of negative 1. So when we have a number with a negative, you can take it out and put an I in on the outside. So negative square root of 6, square root of negative 6, take that out and put an I, so you get I square root of 6. So it's a long explanation, but you should remember this from Algebra 2. So I have a negative 2. So that just becomes x equals plus or minus I square root of 2. I took the negative out and turned it into an I. So our answer is x equals plus or minus I square root of 2. Always put the I at the front. and plus or minus the square root of 6. And so that's your 4 terms, your 4 zeros. So we should always get the right amount now. If there's 4, we're going to get 4 answers because we can give every kind of answer now. Real and irrational, rational, irrational, and complex. Okay. So another quadratic pattern here. So let's go to a different one because that's going to be very similar. Let's go to, oh, you can't see these. I will write in what it is. Okay, f of x is equal to x fourth minus 16. So this is the same thing as x squared minus 4, x squared plus 4, right? Isn't that the difference of squares, only a higher degree? Foil that back if you need to. That'd be x to the 4th plus 4x squared minus 4x squared minus 16. All right, this factors to x plus 2, x minus 2, but this does not because it has a plus. So you have to say x squared, remember this is equal to 0, x squared equals negative 4. So you get x squared, or x, sorry, equals plus or minus I square root of 4. So taking that negative out. Did I go too fast there? Let me go slower and show you each step. That would be the square root of x squared equals plus or minus the square root of negative 4. So that's x equals plus or minus, you're going to take the negative away and turn it into an I. So I square root of 4. And then that's 2, right? X equals plus or minus I times 2. And now we turn it around. We always put the 2 before the I. If it's a radical, we put it at the end. If it's a number, we put it at the beginning. I'm sorry. That's just the way it is. So x equals plus or minus 2I. So back down here, we had x equal plus or minus 2. So all together here, we have x equals plus or minus 2I and plus or minus 2. All right, let's go to number 5. Okay, we have a factor here. Let's factor by grouping because it looks we have 4 terms and it looks like I can pull x minus 2 out. So we're going to say x, get this first group and this group. So x squared, x minus 2, plus 1 times x minus 2. And so that will factor to x squared plus 1 and x minus 2. Set that equal to 0. And you get, okay, right here, x squared plus 1 equals 0 gives me a negative on the right side. X squared equals negative 1. So x, take the square root of both sides, equals I square root of 1, or square root of 1 is 1, so it's just I. Oops, don't forget plus or minus. I forgot plus or minus, so plus or minus I. So for that side, x is plus or minus I, and for this side, you get x equals 2. So your answer is x equals plus or minus I and 2. And we had a 3rd degree term, and we have 3 zeros. All right, let's see. Do we have more? All right, let's do number 7. 5, 4. Okay, so let's see. How are we going to do this? Does grouping work? I think grouping might work for this guy. Let's try grouping again. This time, let's take a x to the 4th out. So this is one group and this is one group. So we're going to say, let's take out x to the 4th, and we get 2x minus 5 minus 1 times 2x minus 5. Okay, so that gives us x to the 4th minus 1 and 2x minus 5. So this guy's no problem. He's going to be x equals, so that equals 0, x equals 5/2. And this guy is going to go to, oh, this is a difference of squares, x squared plus 1, x squared minus 1. We can still go, this one is x plus 1, x minus 1. But this is not a difference of squares because it has a plus, so this we have to just say, use our square roots, x squared plus 1 equals 0. So x squared equals -1. So take the square root of both sides, and you get x equals plus or minus I square root of 1, or plus or minus I. Okay, so let's see. We had plus or minus I. We had, this gives us x equals plus or minus 1, and that gave us 5/2. So altogether we should have, this was a 5th degree polynomial, we should have 5. So x equals plus or minus 1, plus or minus I, and 5/2. Okay, so that's 5. 2, 4, 5. It's kind of crazy. Let's make sure we see it again. This one was normal, just 5/2. This one was, right here, was a difference of squares. X squared plus 1, x squared minus 1. X squared minus 1 was a difference of squares, so that becomes x plus 1, x minus 1. I went down 1 degree in term. So there's my x plus or minus, x equals plus or minus 1 as my 0. And then this was the one that had the complex. Okay? All right, so I'm going to stop the video and we'll start with number 2. 2.9 number 2 is up next.